Hi everyone. In my today's session, I'm going to explain about a behavioral design pattern called Iterator. So, what is a Iterator design pattern? The Iterator pattern is a design pattern in which an iterator is used to traverse a container or a collection and access the container or collection's elements. The iterator pattern decouples algorithm from containers. Okay, so the main idea behind this design pattern is that the basically algorithm of traversing a collection, okay, and the collection itself are decoupled. Okay, that's what they say. The iterator pattern decouples algorithm from the containers. In some cases algorithms are necessarily container specific and this cannot be decoupled. In very rare cases the logic of traversal is also integrated with the collection, and that is very rare case. Okay, the iterator design pattern allows sequential access to elements without exposing the inside logic. Do remember this, guys. Okay, the iterator design pattern basically allows you to access the elements of a collection sequentially, but without exposing any of that iterator logic, which basically gives you one element by one. Okay, thus that means using the iterator design pattern, we can access the elements of a collection in a sequential manner without knowing its internal representations. So, what problems can the iterator design pattern solve? Okay, the elements of an aggregate, which is a collection. Okay, the elements of an aggregate or a collection object should be accessed and traversed without exposing its representation. So, what data structures you are using, no need to see that basically. New traversal operations should be defined for an aggregate or a collection object without changing its interface. Okay, so you can basically specify the new traversal operations. If you take an example of tree data structure, okay, for the tree data structure there are three types of traversal: in order, pre-order, and post-order traversals. Okay, for a list you usually go in sequential way. Okay, the front from the first element to last element. Okay, but in case of tree you can see it's a hierarchical data structure and has more than one traversal option. So you can basically specify those three algorithms without changing the tree data structure. Okay, without affecting the tree data structure class or the tree class. That's what they are saying. Defining access and traversal operations in the aggregate or collection interface is inflexible because it commits the aggregate or a collection to particular access and traversal operations. Okay, so if you specify the algorithm of accessing elements one by one from a collection into the collection class itself, right guys, it will basically couple it. Okay, it will basically, it commits the aggregate or collection to particular access and traversal operations. Okay, you are basically coupling both of these things and makes it impossible to add new operations later without having to change the aggregate interface, okay, or the collection interface. So that's why if you see, even in the C# programming language, okay, the collection interfaces are different, whereas the approach or the logic of accessing elements from a collection interfaces is always different. Okay, C# implements iterators, okay, using the yield return statement, which I have already explained in my previous video. So which is internally implements a iterator design pattern as a state machine and performs the extraction of elements from your collections, whereas your collection interfaces or collection concrete classes are different. Okay, your collection class doesn't contain the logic of extracting elements from an collection class. Okay, it just has one purpose, which is holding a collection objects. Okay, or holding the sequence of elements in your collection object. What solution does the iterator design pattern describe? Okay, define a separate iterator. Okay, define a separate iterator object that encapsulates accessing and traversing an collection object or aggregate object. Okay, that's the first thing. Clients use an iterator to access and traverse an aggregate without knowing its representation. Okay, clients use an iterator to access and traverse an collection without knowing its representation. So for this iterator, what data structure you are implementing, how you are doing, no need to worry. Okay, clients are not required to worry about it. Okay, they just make use of an iterator and they will traverse through the, or they will access the elements of a collection basically. Different iterators can be used to access and traverse and aggregate in different ways. Example is tree data structure, okay, or a tree collection you can say. Okay, so you can specify different iterators to perform pre-order, post-order, and in-order traversals of your tree data structure. Okay, so That's what they are saying. You can basically provide different algorithms to access elements from an collection. Okay, see how cleanly decoupled, how the collection as well as the iterators are cleanly decoupled. Okay, that's why you can provide various implementations to access the elements of a collection or a aggregate. Okay, new access and traversal operations can be defined independently by defining new iterators. That's what I already explained. Okay, so you can basically specify new access and traversal operations by providing a new iterator. Okay, independently by not affecting the collection class or interfaces. Okay, so that's the solution your iterator design pattern provides. It's the UML class diagram. Okay, I will explain it soon. So let's go through the demo now. So I have created a class. Basically, a collection is a sequence of elements. Okay, a collection is a group of elements, you would say. So first I have specified that element or the item, collection item. Okay, for what item or a element I'm creating my collection? It's for student. Okay, just a trivial example. So I have a class called student which has two attributes, id and name. Okay, so this is my item which is going to reside in my collection. Okay, then I'm going to create a interface for abstract collection. Okay, so I have an interface for my abstract collection which provides only one method. Okay, which is called create iterator. Okay, that create iterator basically returns me a iterator. Okay, so this is about the I abstract collection. Then I will create a concrete collection class. Concrete collection implements I abstract collection. Now this maintains, okay, this maintains a buffer of elements or a sequence of elements basically inside it, this concrete collection. So what I'm doing, I'm basically using the C sharp list type. Okay, so that is the approach I have taken. You can use arrays also, it's up to you, or any kind of custom collection you want to maintain inside this. Okay, so list of students I'm maintaining here, and see I'm providing a implementation for create iterator. Okay, so public iterator create iterator returns new iterator object. And what we are doing, the most important thing, okay, how these two things are connected, the collection and the iterator. Okay, see whenever you construct a iterator object, you pass the collection, okay, as a parameter. You pass the collection as a parameter to that iterator object's public constructor. Okay, so for what you are creating a iterator, it should be for a collection, right, for aggregate. So that aggregate or collection should be passed. So in my case, this concrete collection itself is my collection, so I'm passing this. Then I'm specifying some methods like public int count. So at any instant of time, how many elements are there in my collection, concrete collection will this particular property will help me to get that information. So what I'm doing, simple, return students dot count. Add, very simple, as you are passing a student object and I am adding it to my inside collection. Okay, students collection, students dot add. Okay, public student get, if you pass me the index position, okay, so it will return me the ith index or the ith item in my collection basically. So return students of index position. Okay, so you can basically extract specific element from your collection by using its index. Now go to the interface for the I iterator. Now see how iterator is basically specified through a contract or interface. Okay, interface I iterator. First of all, see, first, in order to get the first element of my collection, I should have a method. So I have a method called first which returns a student object. Okay, so you can make use of generics and you can pass any type of object you want. For a demonstration purpose, I'm making use of one specific type. Then next, okay, so your iterator pattern works like that. First you will get the first element of your collection, then you keep on calling the next method in order to get the next element in your aggregate or collection. So next basically returns a next student object available in the collection. And then a flag is completed. Is completed basically tells you whether you have done with the traversal or accessing the elements till the end of your list or not. So this will be true when there is no element to go there is no element to extract further. Okay, so is completed will become true when there are no more elements are remaining in the list. You have reached the end of the list basically. Okay, in that case it will return is completed equal to true. Okay, then the concrete implementation class iterator implements iterator. Okay, so I'm holding a reference variable or a pointer to my collection, that's private concrete collection. Okay, private int current equal to 0. Okay, so my traversal always starts from the zeroth element. Okay, that's why my current e has been set to 0, and also private read only int step equal to 1. Okay, by what value I should step into my collection, either by one element at a time or two elements at a time, that you can specify over here. So the standard approach for most of the collections is, and the very a realistic use case scenario is always one. You always access elements one by one from a collection. So that's why it has been set to one. And see the constructor of this concrete iterator, public iterator, concrete collection. Okay. So for which collection you are basically attaching this iterator. Okay. That collection will be received through this public constructor and will be assigned to this concrete collection reference variable or class member variable, you would say. Okay, it's a pointer to your collection basically. Okay, they are loosely coupled and they are connected together by this reference variable. Okay, now public student first. Now I'm implementing my first method in I iterator, the first method. So what it should do, it should return the first element. So what I'm doing, current equal to 0. Okay, the current has been set to 0 and return collection dot get current. Okay, if I go to my collection interface, I have a method to get elements by its index position. So collection dot get of, if I pass current equal to 0, then it will return zeroth element. So that is the first element basically. Okay, then next public student next. So what I have to do in order to access next element, I have to increase my pointer value or my index value by 1. Okay, so how will you get the next element? You have to increase your pointer by 1. Okay, or index by 1. So I was in zeroth element. If I want the next element, the index value should be incremented by 1. So that's what I'm doing here, current plus equal to step. Okay, so if it is not completed, if is completed is, if this particular thing over here. Okay, if I am not done with the traversing my collection at whenever it returns false, okay, then only I will get the element from the next position in my collection. Okay, so we should ensure that we are continuously checking. So still we have not done with completing the collection traversal. Okay, so if this collection traversal is not yet completed, then get the collection dot get that index position incremented by 1. Okay, once you are done with the traversal, right, it will return anyway false. Okay, in that case you simply return null. That means you are done with the traversal. Okay, is completed, simple logic. If the current index value or the pointer, if the current index pointer's value is greater than or equal to collection dot count. So basically, if the index value is greater than the count of your collection, then yes, you are done with the traversal. You have reached the end of the list. Okay, you have reached the end of the collection. Okay, through the traversal operation. So in that case, it should return true. Okay, so is completed basically tells you whether you have reached the end of list or not. And then the main program, very simple. See how I'm creating or initializing our various objects here, like the collection, the iterator. Let's go through that. Concrete collection equal to new collection, adding some student objects. Okay, then on the collection object I'm calling the create iterator method. Okay, so what it does, if you go to the implementation, create iterator, see, return new iterator by passing the collection itself as a reference. This collection itself will go as a reference. Okay, so when you call collection dot create iterator, no need to pass it by taking this value or passing this value. No, this class collection class will automatically pass that reference to your iterator, and this iterator is now attached to your collection. You can basically traverse through your concrete collection or your custom collection. See, var student equal to iterator dot first. As already I explained, the first will always return the first element in your collection. Okay, print the values. If iterator is not completed, So is completed it is false. Then student equal to iterator dot next. So next will get the next element in the list. You will do this until this is completed is false. Okay, once this becomes true, you are done with the traversal. So by this time you would see all the elements rendered on your screen. Okay, let me show you that quickly. So I'm done with the traversal, and see I'm able to traverse through each and every element in my custom collection. Okay, so that's the power of iterators, and most of the programming languages have implemented their collection traversal mechanism or elements access operations using this iterator design pattern only. Okay, and they provide or they construct these iterator objects automatically for you guys, like Java and in C sharp they automatically create a state machine, which state machine class is basically a iterator class for your collection, whatever kind of collection you are making use of. So everything happens automatically, so you just traverse through this kind of collections using the for each loop, but internally that for each loop makes use of your iterator. Okay, so now I will go to the UML diagram. Okay, so as I already explained, aggregate is nothing but your I aggregate. Okay, I abstract collection. In my program's case, it is I abstract collection. Okay, which has a create iterator method. Okay, same way I'm creating a concrete collection class by inheriting from or by implementing this interface I abstract collection, and I'm providing a implementation for create iterator. And how I create the iterator? By creating a iterator object and passing my collections reference, that is this pointer. Okay, then from the iterator side, yeah, you have iterator interface which has next and is completed also. One extra here it is not mentioned. We have also one flag called is completed, which will tell me when I reach end of the list. And there is a concrete iterator which will provide implementation for the next method, has next method. Okay, and the first method also. Yeah, first is also missing here. Okay, so that's all about the iterator design pattern basically. Okay, so your concrete aggregate. Okay, your concrete aggregate is the class which will basically create your iterator. Okay, so there is a create iterator method which basically create the iterator for this particular concrete collection. Okay, and that iterator will basically traverse through all of your collection elements. Okay guys, so that's pretty much from the iterator side. Okay, I hope you people understood the crux of this particular design pattern. Very easy. Okay, so that's all from this particular design pattern. Thank you for listening and have a nice day.